When you declare a class, you use the keyword class and give it a name. A simple class declaration looks like this. But there are some modifiers that you can specify that further refine the definition and some characteristics of the class. They can be used individually and they can be used in combinations as long as they don't conflict. For example, you can specify that a class be publicly available. The keyword public specifies the accessibility of the class. If it's declared as public, the class is available everywhere. A public class can be loaded and instantiated by any class anywhere. When you declare a class as public, it must be a top-level class. That is, the definition cannot be nested inside another class. If you don't specify the access of a top-level class definition, the default is for the class to only be accessible to other classes that are inside the same package. A package is a collection of class and interface definitions. I'll have more about packages later. A nested class can be declared as protected. That makes it available to the class it's defined in, and it's also available to subclasses of that class. But it's not directly available from outside the class or outside instances of the class. A nested class can be declared as private. That makes it available only from inside the class in which it is nested. It cannot be accessed from outside the class, and it's not inherited by subclasses. If you declare a class as abstract, that means the class definition is incomplete. The class cannot be instantiated into an object because it contains one or more abstract members that cannot be created. There are three ways to get an abstract class. 1. This class could contain an abstract method definition. That is, there could be one or more methods without an executable body. 2. It could be that one of the superclasses is abstract and that this class does not define a body for the inherited abstract method. 3. An interface is not fully implemented, which means that one or more abstract methods still exist. If any of these three cases exist, the compiler will require that the class be declared as abstract and it cannot be instantiated. However, you could have a fully defined class, otherwise complete, but declaring it as abstract will make it abstract whether or not it contains an abstract member. A nested class, a class inside a class, can be declared as static. It means that the inner class can be instantiated by itself without the outer class being instantiated. That is, it becomes a regular class definition, except you can only refer to the class by name by using a dot reference in using the name of the outer class. For example, if you have an outer class named outer with an inner class named inner from another class, you could create an instance of it with a statement like this. Now, this is rare. There isn't much reason for defining a static inner class this way. The only thing it does is convert an inner class into a normal class, except that you have to use the name of the outer class when you refer to it. I found it handy a couple of times while I was debugging, but that's all. If you want to forbid subclasses, you can declare a class as final. A class declared this way cannot be extended into another class. Some of the classes in the Java API are declared this way. One of those is the string class. You cannot extend it into a string class of your own and add stuff to it. I don't know why exactly, but that's the way it is. The strict FP modifier makes all operations using float or double inside the class follow the strict FP rules. Without this specification, there is some leeway that the compiler can use for speeding things up by taking some liberties with the way intermediate values are calculated and used and what have you. If you want more information on this, check with the IEEE 754. Those are the modifiers for defining classes. You can use many of them in combinations, but some of them you can't. For example, a class can't be both public and protected, but a class can be strict FP, final, and public all at the same time. Logic will tell you which combinations work together. Besides, if you get it wrong, the compiler will mention it to you and give you the opportunity to make a correction.